Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimum length of string after operations. Leetcode 3223. In this problem we are given a string s and we can perform the following process on s any number of times. We choose an index I in the string such that there is at least one character to the left of index I that is equal to character at ith index and at least one character to the right that is also equal to character at ith index. And then we delete the closest characters to the left and right of index I that is equal to ith character. And in the end we should return the minimum length of the string s that we can achieve. Then in example 1, for the given string, we can choose this character a because it has at least one character to the left of it and right of it which is equal to a. So we will get rid of nearest such characters. So now our string becomes BAC, BC, BB. So now A does not have any identical character to it on its left and right. So now say we move on to B, and now B has two characters on its right and one character on its left which is identical to it. So we will delete the nearest one. So we will delete this B and this B. So now our string becomes AC, BC, B. And now this B does have one identical character on the right of it but not on left of it. Similarly, this B doesn't have any character on the right of it which is identical to it, but it does have on the left of it. Now let's come to C. And now this C, for example, doesn't have any identical character to the left of it, and this C doesn't have any identical character on the right of it, so we cannot delete them as well. So this will be our minimum string after performing these operations, and the length of the string will be 5. So in terms of solution, when we hear nearest left or nearest right, we might think of technique like monotonic stack or two pointers, but this problem is actually simpler. If you observe carefully during the example walkthrough, we were removing two characters, one at the left and another at the right. So that means to remove the two characters, we need at least three identical characters. One on the center, one on the left and one on the right. And we can remove the left and right characters symmetrically. So that means if we have three identical characters, we can remove two of them. But if we have one character, like we only have one A, or we have two identical characters, like we have string AA, in this case, we cannot remove the characters. So the minimum number of identical characters required to perform a removal is 3. So then our approach can be that we count the frequency of each character, and then for each character, if the frequency of the character is 3 or more, we can keep removing the pairs until we have fewer than 3 remaining. And these remaining characters will contribute to the final string. So sum of all the remaining character frequencies will be our answer. For example, for the given string in example 1, frequency of A is 3, B is 4 and C is 2. So now we will go through the frequencies. Frequency of A is 3, which is greater than or equal to 3. So we can remove 2 A's. So now the remaining frequency will be 1. And then for B we have 4 characters, again greater than 3. So we will reduce it by 2. And now remaining frequency becomes 2. And finally frequency for C is 2, which is already less than 3. So we cannot do any further reduction. So the total number of characters remaining for A, B and C are 1, 2, 2, which adds up to 5. So the length of the minimum string we can form performing these operations is 5. And now if we observe this logic, say we have 5 identical characters, say we have 5 A's. Since frequency 5 is greater than or equal to 3, we can remove 2 characters. So now frequency becomes 3 and 3 is again greater than or equal to 3. So we can again reduce it by 2. So now eventually we have 1 remaining A. And this pattern holds for any odd number of characters, because if we continue to subtract 2 from an odd number, eventually we will come down to number 3 and then to 1. So characters with odd frequencies will end up with 1 remaining character in the end, and hence it contributes 1 character to the final string. Similarly, if the character has even occurrences, like say we have 6 A's, it will come down to 4, then it will come down to 2, and since 2 is less than 3, our loop will stop. So in the end, for even occurring characters more than 0, we will have 2 remaining characters, and hence it will contribute only 2 characters to the final string. So then our logic can be even simpler. For each character, we calculate the frequency of it, but this time for each frequency, we check if the frequency is odd, then we will add 1 to our answer, but if the frequency is even, then we will add 2 to our answer. Now let's see this in action. So here we can see that A's frequency was 3, which is odd. So it will contribute 1 to the answer. B's frequency is even, so it will contribute 2 to our answer. And C's frequency is even as well, so it will also contribute 2 to our answer. So total number of characters remaining after performing these operations is 5, which is also equal to the length of our minimum string. Now let's jump into the code part. First, let's initialize the array of size 26 to store the frequency of each character. Since we are dealing only with lowercase English letters, instead of using a frequency map, we can use a frequency array. Each position in the frequency array corresponds to a character's position. For example, frequency for character A will be stored at index 0, B at index 1 and so on. Let's also initialize variable total length to track the final length of the string after performing these operations. Now we will iterate through the string, and for each character, we will increment the corresponding index in the frequency array. We can get the index of the character by subtracting the ASCII value A. Now we will go through the frequency array, and if frequency is 0, then we don't have to delete anything. So we will continue. But in case frequency is even, we remove all the characters except for last two ones. So we will add 2 to our total length. And if the frequency is odd, we will add 1 to the total length. And once we are done with all the frequencies, we will return our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is number of characters in the string. Because first we are going through the characters in the string to build the frequency map, and then we are going through these 26 frequencies, which will add O1 to our answer. So overall time complexity says O of n. And in terms of space complexity, it will be O of 1, since the size of the frequency array is fixed and it contains only 26 lowercase English letters. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.